Hello, I'm excited to present the second Shiny app that will help you create Seurat files and store them in your R environment to be used with the Ryabhatta app. Here, I'm going to show you how to create a Seurat file from a 10x output. I will perform quality control analysis and dimensional reduction on the data to create a UMAP plot. Let's get started. Click on the Create Seurat file from a 10x output button and then click Browse to select the files that are as presented as outputs of 10x. 10x outputs created by the cell ranger pipeline are stored as raw count matrix files and genes and barcodes associated with the matrix files. Select all three files and click Open. This will load all the files into the current working environment. Click on Proceed to creating Seurat files. PBMC stands for peripheral blood mononuclear cells. Now create Seurat file. This will create a Seurat file and show you options to add metadata such as time points and developmental stage information or any other kind of information that will be useful later on to compare this Seurat file with other ones or integrate or merge data files. Here I'm going to call the sample as PBMC 10x, as this data is derived from 10x pipeline. I'm going to click on Add, and this will give me a prompt saying that PBMC 10x value has been added to sample category. Next, I will choose to perform quality control analysis with the option of including mitochondrial percentage calculation. This will create three violin plots, one for the number of genes expressed per cell, the number of UMIs counts present per cell, and the percentage of mitochondrial expression relative to the total expression within the cell. Each dot shown here is an individual cell and helps you visualize the outliers in the data that need to be filtered out. Use the slider bars on the left to choose which cells and what numerical values you want to use as cutoffs for this process. You can click on Update QC graph to get an idea of how many cells you're losing from this process. Then click Filter Cells and perform PCA analysis. This performs normalization, finds variable features, scales the data, and runs principal component analysis. The output of this step is an updated violin plot graph for each of those conditions, each of those parameters, and an elbow plot, as well as a cluster tree diagram. An elbow plot shows you what is the reduction in the standard deviation with the addition of each and every individual principal component analysis. This is a heuristic approach to determine what is the number of principal components that can be used for further analysis, and is a subjective and sometimes iterative process. Here I'm going to choose 15 dimensional reductions, 15 principal components, and a resolution of 0.2 to get 4 clusters. This will create a dimensional reduction plot with each of the clusters labeled, as well as the number of cells present in each cluster. You can iteratively change and perform this analysis multiple times until you are happy with the dimensional reduction and the number of clusters that you feel are biologically meaningful. Next, you can use the parameters shown here to find markers that are specific for each cluster. This is a process that will take a long time and depends on the computational memory capacity of your computer or the browser that you're using. The end result of this analysis is a heat map that shows you marker expression in each individual clusters. The names of the markers are provided at the bottom as a table. You can now choose to switch to Features View, and this will remove the dimensional reduction plot. At this place, you can click on any of the markers down and that'll show you the expression of that particular marker overlaid on the dimensional reduction plot. You can use this cell cluster renaming tool to rename the clusters based on these marker expressions. Thank you for watching this video, and I'll appreciate it if you could take the survey in the link in the description and help us decide how to make this app publicly available. In the next few videos, I will show you how to create Seurat file from other sources of data, integrate different Seurat files, and perform pseudo-time analysis on Seurat files. Thank you.